As the science of climate change itself became better understood by worldwide experts, the IPCC began focusing its attention on the impacts of climate change on people and economics of the world. Working Group 2 focused on these issues under the leadership, with others, of Mr. Robert Watson of the United Kingdom and the United States. Mr. Watson is Chief Scientific Advisor to the UK Department of Environment, Food and Rural Affairs, and has been an author, chair, and co-chair of this group through the first 3 of its reports. He's joined at his table by Osvaldo Canziani of Argentina, who has co-chaired Working Group 2 for the past decade, but who has been with the IPCC since 1991 and brings to the IPCC his extensive experience in meteorology and hydrometeorology. By Dr. Martin Parry of Britain, a geographer specialist in climate impacts and another co-chair of the Impacts and Adaptation Working Group and a lead author on all of the previous assessments. By Jim McCarthy of the United States, another co-chair of the Impacts and Adaptation Group during the historic 3rd assessment report, and by the Russian Federation's Yuri Israel, who chaired this working group during its first assessment period, 1988 to 1992, and has remained IPCC Vice Chair until now. He's also served as a former president of the World Meteorological Organization and is currently president of the Russian Academy of Ecology. Mr. Bob Watson will remind us of the accomplishments of the Impacts and Adaptation Group today. Bob?
Thank you. It's a pleasure to be here. And this, just like Working Group 1, is the output of thousands of scientists and peer reviewers over the last 2 decades. And a lot of it depends on the excellent work of the co-chairs from the 1st to the 4th assessment reports. In reality, we've had an evolution of thinking from the 1st assessment report to the 4th assessment report. Even in the 1st assessment report, we understood what the key issues were: impact on food, water, human health, human settlements, and to some degree we were concerned about biodiversity. But as we've gone from the 1st to the 4th report, we've got far better understanding of the location of the impacts, the timing of the impacts, the more precise nature of the impacts, how can we adapt, to what degree are we vulnerable, and obviously a major improvement is we now have observations of changes in both physical and in biological systems that can only be explained by the impact of human-induced climate change. In the 1st and 2nd report, we recognised that most of the adverse effects would be at the lower latitudes, although, of course, the adverse effects are at all latitudes. This is called the burning ember diagram, and this, I think, was a fundamental breakthrough in the 3rd assessment report. We noted particularly that developing countries and poor people were vulnerable, small islands, and in particular food, water, health, the very underlying issues of sustainable development. We recognise there are already risks to some people even now, and the risks to many would increase, especially if you went above 2 degrees Celsius. We noticed effectively that ecological systems and biological systems were particularly vulnerable. And if we went much higher to 4 and 5 degrees Celsius, we may see a change in ocean circulation, a disintegration of the West Antarctic ice sheet, and a disintegration of the Greenland ice sheet. By the time we got to the 4th assessment report, it was much more specific. It talked specifically about areas in Africa, Asia, the megadeltas, the small islands, the Arctics. And it identified in a much more quantified way than previously the impact of water, especially in the dry tropics. The dry areas are getting drier, the wet areas wetter. Agriculture, almost any warming would adversely affect agriculture in the tropics and subtropics. Human health adversely affected, waterborne diseases, vector-borne diseases, health, heat stress mortality, increase in malnutrition in the tropics and subtropics. And unfortunately, many ecosystems that are the basis of sustainable development being adversely affected. You can't read this, but it's a very pivotal slide. For the first time in the 4th assessment report, one looked at sectors such as water, ecosystems, food, coastal areas, human health, and singular events. And then, as a function of changes relative to 1990, they would quantify what the impact could be. So even a 1 degree Celsius rise could put 1 to 2 degrees Celsius rise could increase 1 to 2 billion people in water scarcity. Ecosystems, by 2 degrees Celsius, most corals will have bleached. The food, decreases at low latitudes, although some increase at high latitude. So for the first time, and there's a poster outside that you can look at this much more carefully, we've quantified the implications of different changes in temperature and, of course, precipitation on different sectors. They then went further and they actually looked at it by region. So if one's interested in Africa, one can see what are the key impacts on Africa as a function of the projected changes in temperature, or on Europe, or small island states. And as we know, even modest changes in sea level can have very adverse effects on small island states. Africa probably is the most vulnerable of the continents for food, water, human health, and some of the ecosystems. This shows you in one projection, and that is on the left-hand side, what we see is a map of the world. It's for the decade of the 2020s, 2050s, and 2080s. In yellow, it's those areas of the world where we'll have a decrease in agricultural productivity. If it's in green, it's an increase in agricultural productivity. By the 2020, there's probably no net loss of global productivity. But the areas where we have hunger and famine today, the tropics and subtropics, will have less agricultural productivity even by the 2020s. There's no real lack of food today. It's a distribution issue because of poor trade policies. Climate change will exacerbate that even by the 2020s. By the 2080s, we would project a decrease in agricultural productivity, even at a global level. These assume some level of adaptation, but they don't assume major breakthroughs in modern biotechnology, the use of genetic modification for pest, salinity, temperature, or drought-resistant crops. But will modern biotechnology bias those traits? And will they be publicly acceptable? Will they come with either environmental or human health implications? What we can see here, water, a major problem today. A third of the world already water stressed. 2/3 of the world will be water stressed or water scarce by 2025. Climate change further exacerbates that. The tropics and subtropics getting drier. The areas where we produce food in the tropics and subtropics getting particularly dry. We can adapt. This is just one simple issue. One of the major breakthroughs as we've gone from the first assessment report to the fourth assessment report is trying to understand to what degree can we adapt. But are there physical limits to adaptation? Are there institutional limits to adaptation? And are there behavioral issues to adaptation? It's fine developing technologies either for mitigation or adaptation, but we have to understand the economic implications and the social costs. This simply shows that effectively, with enhanced protection, we can protect, to some degree, the coastlines. Much easier if you've got institutional capability, technological capability, and financial capability. But if you're a small island state, or have a complex deltaic area such as Bangladesh, it's very difficult to imagine a really foolproof adaptation strategy. So fundamentally, observed effects of climate change. What we have here is we've got conclusions by region. We've seen major changes in non-polar glacier retreat. 60,000 glaciers are retreating. A significant reduction in Arctic sea ice. And this year may conceivably even go below last year, which was an all-time low in both thickness and extent in the Arctic summer. We're seeing earlier plant flowering and longer growing seasons in Europe. So agricultural productivity at the moment is doing well in Europe. But if we go above 2 or 3 degrees Celsius warmer and we get drying, especially in the southern Mediterranean, we will then see a long-term decrease. We're seeing migration patterns of plants, insects and animals changing. We're seeing changes in when birds arrive on migration and when they lay their eggs. And we're already seeing, unfortunately, increased coral bleaching. We're seeing economic costs simply over time from the 1950s to the decade of the 1990s. We've seen an increase in extreme weather events and we've seen an increase in economic costs. Within developed countries, much of that is insured cost, so it's passed off to insurance companies. But in developing countries, very few people are indeed insured. And so the economic costs have fell again, often on the poorest of the poor. So some of the key findings of AR4, the latest, the impacts are occurring now. This is not an issue for 10 years' time, 50 years' time, 100 years. The impacts are occurring now. We have identified some of the most vulnerable places, small island states, many people in Africa, Southeast Asia. We've actually looked at the projected impacts not only occurring now, but over time. We've started to look at singular events. What would it take to collapse the West Antarctic ice sheet? the Greenland ice sheet, which is melting faster than we can truly understand. How will climate change be another stress on a system already stressed, threaten sustainable development and the Millennium Development Goals? We have to put climate change in the context of multiple stresses. So we have to look at this, as Steiner said, we have to look at the implications on ecosystems and the services they provide. So the key challenge we've got is how do we bring this all together? Again, you can't read this, but Martin Parry with a couple of co-workers actually took the impacts document, how would different sectors be affected by different changes in temperature, and then he asked the question, how do I bring this together with Working Group 3 on mitigation? And what this shows is, relative to today, even with an 80% emissions cut by 2050, 80%, we would still project probably in the middle about 1.2 degrees Celsius increase. We've already seen 0.7 degrees Celsius increase since pre-industrial. So even an 80% cut would say, relative to pre-industrial, probably a 2 degrees Celsius increase. If we only have a 50% decrease in emissions by 2050, by 2100, we'll be seeing about a 1.7 degrees Celsius rise relative to today, 2.5 degrees Celsius relative to pre-industrial. If, on the other hand, we've got unmitted climate change, and it's one of the central projections, we could be seeing 4 or 4.5 degrees Celsius. In other words, what Martin tried to do is bring together the results of Working Group 2 with the results of Working Group 3. And this shows that if we want to limit damage, we need major decreases in greenhouse gases now at a global level that are also equitable. And lastly, what further actions are needed? We need to look far more at the economics and the technology and the non-English language literature. We've got to look at behaviour far more than we've done before. We need to get managers as well as scientists involved in the IPCC. We need the other UN agencies. Every part of the UN system needs to be involved. We've got to integrate, in my opinion, the 3 working group reports much better than was even done in the 4th assessment report. We need a true synthesis report, basically. And while the World Climate Research Programme under WMO has done a superb job of trying to look at the physical system, the World Climate Impacts Programme has fallen into disarray. It's about time that we not only assess what we know about impacts, but we need to bring together an integrated way of looking at impacts, and we need to revive the World Climate Research Impacts Programme. Thank you.
Thanks, Bob.